Now for the composite function, okay, fg to exist, alright, the condition states that the range of G must be a subset or equal to the domain of F. Okay, so this means two possibilities. Alright, the first possibility will be when the range of G is equal to the domain of F, or when the range of G is a subset of the domain of F. So let's discuss the first case first, right, which is the case whereby the range of G is equal to the domain of F. Now, why must it be so such that for the Fg to exist? Well, think of it this way. All of us understand function as a something like a machine, right? So we put in a domain, put in an x, and then out comes a y. So generally, let's imagine that we have a domain of x, the domain of g, and the range of g. Okay, so let me finish drawing this first. Okay, so the composite function serves something like a shortcut. So it's like an fg, a shortcut. Okay, that maps a certain value when you put it in, and it becomes an outcome. Okay, now when you say fg, what we are going to do is that we're going to undergo the transformation g first, and then followed by f. Okay, so it's a little bit in the wrong direction. The fg means you actually do g first, and you follow by doing an f. Okay, so now let's color code it. So let's say our g is a rate function. Okay, so what we have is, of course, x1, x2. So these are known as the domain of G, which is the input that you're going to put inside G, right? So when you put x1 inside G, outcome will be y1. And when you put x2 inside G, and outcome will be y2. Okay, now this y1, y2 will be known as the range of G. Okay, so these are known as the range of G, which is the outcome of G. Now, this outcome of G is going to be put inside this function called f. Now let's again color code it. So let's say our f is a blue function. Okay, so happen that under this case, okay, we have the range of G being equal to the domain of f. So in other words, the domain of f, whatever the input that we can put inside f, is also simply y1, y2. Okay, there isn't anything extra or anything more than y1, y2. So this is what we say when the range of G is equal to the domain of f, exactly equal. Right? So when we put in the y1 inside f, it becomes z1. Okay, and we put in y2 inside f, and we get z2. So in this case, as you can see, nobody is left nowhere. Correct, everyone from x1 to x2 is accounted for here and becomes z1, z2. So there isn't any lost in translation along the way. So therefore, this shortcut can exist. Okay, so this is the first case whereby the composite function actually can exist. Now let's talk about the second case. Okay, now the second case says that, well, the composite function, which is the shortcut, can exist if the range of G is a subset of the domain of F. Okay, so similarly, it's very similar to this picture over here that we have. So let me try to draw the three circles one more time. Okay, so again, we are trying to investigate if the shortcut fg exists. So fg is here. Okay, so this is a shortcut fg. So we have a rate function, which is the g function g. Okay, and function g, the domain of function g is x1 and x2. Okay, so undergoing G, x1 becomes y1, okay, and x2 becomes y2. So this collectively, the rate y1, y2, these are known as the range of G. Okay, so of course, next come the function f. Okay, now function f is another function, which is the second one that we're going to put it in. All right, it's the blue function. So y1, y2 happen to be inside the domain of your f. Okay, so the domain of f is a bigger set now. Okay, so domain of f, which means that there are actually more values beside y1, y2. Okay, so there could be a y3. Okay, and there could be a y4. Okay, and many more perhaps, which is why y1, y2 is known as a subset of the domain of f. Okay, now what happens here is that this y1, y2 undergoing f will become z1 and will become Z2. Following, okay, but because there are others around, so think of it this way: the y3 will then become z3, and the y4, oops, gonna get a little messy here, will become z4. Okay, so in this particular case, I need you to understand that in this particular case, we have the domain of G, okay, being mapped over and become the range of G, which is this red circle y1, y2 here. This range of G is a subset of the entire domain of F, which means just a small little part of it. And well, eventually, the y1, y2 becomes z1, z2 at the final destination. Again, okay, from here you can see that nobody is lost anywhere, right? So this x1, x2 is all accounted for. At the end of the day, they become z1, z2 again. So this fg can exist. Okay, so after talking so much, you go like, oh, okay, well, yeah, now I understand more or less that they exist. Perhaps it will be easier for you to understand why these two conditions has to be true in order for your fg to exist by showing you when it doesn't exist. Okay, well, it doesn't exist when this scenario happens. Okay, so let's take a look. Alright, of course the scenario you do know that when it's not a subset and when it's not equal. So now let's think about it. Okay, let's color code it again. We have first function being g, okay, and we have our x1, x2, okay, and the second function being f. Okay, now here comes the interesting thing. Alright, now it happens when our fg doesn't exist when this happens. Okay, when I x1 map over becomes y1, my x2 map over becomes y2. Okay, but I have another x3 which when I map over, okay, falls outside the domain of f. Okay, which means that, well, the domain of f is too small to accommodate this entire range of y1, y2 and y3. Okay, in other words, what happens is this. Okay, so this y1, y2 is going to be only the part of the domain of f, right? It's going to be the domain of f. So when you map over, okay, it becomes z1 here, and when you map over, it becomes z2. Okay, so you see the problem here? Okay, the problem here is that somebody is lost, and that somebody happened to be x3. So there isn't any z3 around. So in this case, you cannot say that the shortcut exists, because this shortcut will not work for x3, because when you map x3 over, the y3 falls outside whatever they can put inside the f. So in this case, the y3 will not be reflected here as z3, and therefore this original point of your x3 is already lost along the way. Okay, so this is why, okay, for the fg to exist, then the range of g must be equal or subset of the domain of f. Right, now let's understand a little bit more about the composite function. Okay, let's scroll down a little. Okay, now, so if my fg were to exist, okay, if fg exists, okay, what happened is this, right? The domain of your fg will be equal to the domain of g. Right, now this is true for both cases, for both case 1, okay, and case 2. Right, as long as the fg exists, the range of fg, which is the range of the domain of fg, which is the domain of the shortcut, right, will be simply the domain of g. Okay, so think about it. Why is this so again? Well, because if fg were to exist, whatever numbers that you can actually put inside fg must come from somewhere, and those numbers are actually x1, x2. So these numbers x1, x2 are actually simply the domain of g. So whatever you can put inside this fg comes from the g. Okay, now similarly here in case 2 comes from the g, and which is why this is always true for either case. So as long as the fg exists, well, this will be true. Okay, now let's talk about the range. How about that? Okay, but we still need to take a look at this this picture. Okay, so if my fg were to exist, then the range of the fg Okay, well, it really depends on which case now. Okay, so for case 1, whereby we all understand that case 1 is the equal case, okay, where the range of G is equal to the domain of F. So when it happens this way, when the range of G is equal to the domain of F, and therefore the Fg exists, the range of Fg is actually equal to the range of F. Now this is a very, very useful and important fact, simply because in many questions you will be asked to find the range of Fg, and if you do know this identity, you do know that the range of Fg is actually the range of F, then it can save you a lot of trouble sometimes. Okay, all right. Let's investigate why is this so again. Okay, now in this case, as you can see, because the range of G, the range of the rate function, okay, is totally equal to the domain of F. So there's no extra y3, y4, there's no one falling out of the domain of F. So everyone is accounted for and everyone is intact. And when you fly over, everyone becomes Z1, Z2. So in this particular case, you realize that your x1, x2 were to put in, if you were to put in your x1, x2 into your shortcut, and outcome, it would be simply Z1, Z2. Okay, so it's pretty easy to understand, and hopefully it's pretty easy to remember. Now, but it doesn't really work this way under case 2. Let's investigate a little bit. Now, if your Fg exists under the scenario whereby it's a subset case, like in this case a subset, okay, then all we do know is that the range of the shortcut, which is the range of Fg, is simply a subset of the range of F. Okay, now this knowledge is not very useful. Okay, why is it not very useful? Well, let me try to explain a little bit why or what's going on here first. Okay, so basically, if you have the composite function existing because the range of G is a subset of the domain of F, like in this case, a subset. Okay, I need you to, well, let's try and see if I can make you understand a little bit better. So whatever function, whatever values I can put in comes from the G, and these are the rate values, right? So these rate values, x1, x2, I put inside F. Outcome will not be the entire z1, z2, z3, z4. Agree? Because I only put in x1, x2, and outcome will be, obviously, it's just simply z1, z2. Okay, so why are there z3, z4 is simply because at the first place the domain of F is way bigger. So you know that, you know, whatever you map over, you get y1, y2, hey, but there are more, right? There are y3, y4s all over the place, and therefore when you go to the range of F, which is this entire circle here, you have a lot of other values around, which is your z3, z4, and so on, which we are not really interested in because we know that we won't get z3, z4 from Fg, because the input of Fg is only x1 and x2, and therefore the outcome should be simply z1 and z2. So as you can see, in this case, it's merely a subset, okay, which is what we're discussing over here. It's a subset of the range of F. Now, why do I say that this is rather useless? Well, simply put this way. Now, if you know that the range of F, let's say the range of F is from 0 to infinity, and therefore I know that my range of Fg is a subset of this. That doesn't tell me much because yeah, range of Fg is a subset of this. All you can conclude is that, well, it has to be you know, between 0 to infinity, so it could be from 1 to 2, inclusive, exclusive, it could be 1 to 10, it could be anything else, and therefore this piece of information is not useful at all. Okay, and when this happens and you need to find the range of Fg, well, you have more things to do. You have to do more workings. Okay, so generally, what we'll just discuss here, to keep the lesson short, so that we can move on to the next part, if you know. Okay, so what we just discussed over here will be simply when, okay, how to determine whether a composite function Fg exists. Okay, and I described to you the two cases here whereby they exist. Hopefully it makes more sense to you, and then you can understand it better.